So here's a video. I have a couple of thoughts on this Khan Academy question that I wanted to share with you because it has one sentence in it that could lead you astray. And so I think it's important to, I don't know, disambiguate those. But anyway, what it is the question says, Rodrigo plans to buy packs of baseball cards until he gets the card of his favorite player. And the danger, I think, is that you might read this as a student and think that this is uh, a waiting for something to happen event because it's phrased that way. And that's how we generally teach you to look for the exponential or geometric, depending on what your textbook calls it, the type of question where you're waiting for something to happen, like a light bulb. What's the probability that it lives for, lives isn't the right word, but hopefully you know what I mean, fails to fail in the first 10,000 hours of its life, or the probability that a vacuum cleaner will break down before the warranty period is up. Things like that. You have a single event and you're waiting for it to either happen or not happen, and that's what this looks like because he plans to buy packs of baseball cards until he gets the card of his favorite player. But there's a but. It says he only has enough money to buy at most 3 packs. So we're not actually waiting until he gets the card of his favorite player. We're going to buy at most 3 packs, and we're going to calculate the expected value of this random variable that we'll talk about. But anyway, we're not actually saying, what's the probability that he has to buy 10 packs of cards before he gets the one he's looking for. So be careful about that. And another kind of thing you can use to determine what kind of question this is that in these lifetime or mean time to failure questions, you're only given one piece of data, and that's mu. That's the mean lifetime of the that's been determined for the type of object you're looking at, and that's because that's the only parameter that's needed for this this type of curve, where they break down over time, and so it becomes 0, but not for a long time. The shape of this curve is completely determined by the parameter mu. Compare that with this question where you're being asked to calculate mu. So that's another hint that this isn't a lifetime question. It's something else. And in fact, if you ignore everything above the line, you would probably get the question right anyway. I kind of hate to say that, but all the information above the line is encapsulated in the table for you. He's going to buy at most 3 packs. Each pack has a 10% chance of containing the card he's looking for. So if he buys 1, there's a probability of 10%, 0.1, that he gets the card he's looking for. Another reason I like this question, I wanted to talk about it. If he buys 2 packs of cards, there's a 0.09 chance that he gets the card he was looking for, because in this scenario, what must have happened is he bought the first pack of cards, and we were in the 0.9%, sorry, we were in the 90% or 0.9 probability that he did not get the card he was looking for, because otherwise, why did he buy the second pack of cards, which had a 0.1 probability of the card he was looking for? And so that gave him, this gives us the probability of 0.09 that this event occurred. Now, contrast this with the situation with the walleye and the pike, where having 2 fish and one of them was a walleye and one of them was a pike, we had the probability of that, but we multiplied by 2 because getting a walleye and then a pike was the same as getting a pike and a walleye. Not the same in this question, because if he gets the card he's looking for when he buys the first pack, he doesn't buy the second pack. It's almost like a conditional probability, but I probably shouldn't muddy the waters that way. The third option is when he did not get the card he wanted on the first 2 purchases, so 0.9 squared times the probability that he did get the one he wanted on the third, which was 0.1, so there's our 0.81. And now all of that's been calculated for you. This question just requires you to do what the other questions in this section do, which is to take each of the values of x, multiply it by the probability. So we get 0.1, 0.18, 2.43. This is the third time I've recorded this video, so I have these numbers memorized already. And when you add them up, that dot was not supposed to be there. When you add them up, you get 2.71, and that is the expected value or the mean in this question. So there you go.